Okay, today we're going over CC1 4.2.1 review and preview. Problem 47 says to use graph paper to complete the steps below. Then answer the question that follows. So the steps below are, the first one is to draw a square that measures 5 units on each side. So I'm going to draw a square that measures 5 units on each side. That's 3, 4, 5. 1, 2, 3, 4, 5. And I'm going to make sure that it's a square. Okay. Now, step 2 is to draw a design inside your square. I'm not going to draw a design. I want you to draw your own. Okay. But I don't want it to be something like just a triangle or a smiley face. Draw something a little bit more complicated. Okay, not like a dragon like we did in class. Once you have that done, you're going to draw a square that measures 15 units on each side. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And I go up. Okay. Now what I'm going to do is enlarge my picture as accurately as possible so that it fits inside of the 15 by 15 square. Okay, now I'm going to draw this really lightly. I'm going to use, I'm going to use a highlighter because it's going to bleed through. I'm going to use a pencil highlight. Okay, so 5 to 15, I'm growing by 3. I'm multiplying by 3. So I'm going to try to draw in kind of like a grid system, like what we had in class. Okay, and I'm trying to draw this dark enough that you can see it. Okay, and then I'm going to do that the other way. I'm going to turn the paper sideways so I can do it. Okay. So the reason I do this is so that it matches this. So in class today, this square matched one of the squares in my other one, in my enlargement. Okay, so this square here matches this square here. Okay. So whatever I draw, let's say I drew this shape here. Okay, I would want to recreate it here, just like we did in class. So whatever that shape is. So let's say I made a circle here and then I made like an eyeball. Okay. So this square here matches this square here. So it kind of goes around like this. Okay. And this one goes from about here to like 1/3 there to 2/3 there. So about 1/3 there to about 2/3 there. Then it kind of dips down. And then it kind of follows that line. Okay, so I want to make this as accurate as I can. This circle, really, this goes down like this. It goes all the way around like this because that pupil goes inside like that kind of. Okay, and my eye's still not correct because I think this was supposed to go up higher. So I want to make this as accurate as possible. Okay, so one square here, I'm going to reiterate, this square here is the same as this square here. Okay, and that's going to help you enlarge your picture. When I get to this question here, how much wider and how much longer is your new picture? Well, if I go from 5 to 15, I'm getting 3 times bigger, or 3 times wider and 3 times longer. Okay. Problem 48. Tina is going to put 1-inch square tiles on the picture frame shown below. It says, well, if the frame is 1 tile wide, how many 1-inch square tiles will she need? So remember, if this is 7, okay, really this picture frame goes out 1 more, so this is really 8. Same thing here with this 4. Actually, it's 7 plus 1 plus 1, so it's not 8, it's 9. Same thing here with 4. There's 4 here, but I have to include that, so this is actually 6. Okay? So remember our counting strategies, right? I could have, if I have 9 here, okay, then I could say, well, there's 5 here and 5 here, and then there would be 7 down here. So 9 plus 5 plus 5 is 19, plus 7 is 26. Okay, I couldn't multiply it by 4 because I don't have the same length. I could do 9 plus 9 plus 4 plus 4, which is 18 plus 8, which is 26 still. Okay, so she needs 26 tiles. Part B, would more 1-inch square tiles fit inside the frame or on the frame? Show how you know. Well, inside the frame, I have to find the area of the inside of the frame, which is the area for a rectangle is length times width. My length is 4, my width is 7, depending on how I see that. 4 times 7 is 28. So more tiles fit inside the frame. That kind of looks funny. F-R-A-M. I did too many. F-R-A-M-E. Okay. On the back. Okay, problem 49. 4 friends work together to wash all of the cars that the Kumar family owns. They received $43 for doing the work and agreed to divide the earnings evenly. How much money will each friend earn? Show how you know. So if I'm doing this, I have $43 and I'm dividing it. Sorry, I'm looking at my camera while I'm doing it, not my paper. $43 divided by 4 people. 4 goes into 4 one time. 0, drop my 3. 4 goes into 3 0 times. Drop my 0. 4 goes into 30 7 times. That's 28. 30 minus 28 is 2, and I drop my 0. 4 goes into 25 times. Okay, and I take my decimal point and move it up. Each friend earns $10.75. Problem 50. Complete and copy and complete the generic rectangle. What multiplication problem does it represent, and what is the product? I have to work backwards. 5 times a number is 30, or 30 divided by 5 is 6. Okay. I'm trying to do the outside numbers first. So the next step is I'm going to look at this 800 here and this 4 here. Okay. One of those zeros comes from here. So 4 goes into 80. How many times? Or 40 goes into 80 how many times? Well, 4 times 2 is 8, but I need that 80, so it's 20. Okay, and then this last piece here, 500 divided by 5 is 100. This is 800 divided by 40, and this is 30 divided by 5. That's how I figured those out. Now I can just multiply. 20 times 100 is, I can put my 2 and then put my zeros in. 20 times 6, 6 times 2 is 12. I put my 0. 5 times 40, 5 times 4 is 20, and I add a 0. Well, for what multiplication problem does it represent? It's 146 times 25. And the product, I just have to add all of my pieces of my rectangle. Okay, I know it got kind of small. Zeros all the way down. I have 2 plus 3 is 5. 8 plus 1 is 9. Plus 5 is 14. Plus 2 is 16. 2 plus 1 is 3. My answer is 3,650. Okay, problem 51. Use the portions web, which is this, to rewrite each percent as a fraction, as a decimal, and with words or pictures. So we are going to use words. So if I have 13%, remember I move my decimal. I'm dividing by 100 because remember my fractions are percents are fractions out of 100. So I'm dividing by 100 because the fraction bar means division, which is what moves my decimal point 2 places. Okay, now my words for this one, and I'm sorry I have to turn my paper sideways so I can write it. I have 1/10 and 3/100. I have to have that THS. I could write 13/100. It's the same. Okay, part B, 20%. I have 20%. Percents are fractions out of 100. I divide by 100 to get to my decimal, which is what allows me to move my decimal 2 places over. This is the same as saying 2/10 or 20/100. Part C, I'm going to do the same thing. I have 130%. Percents are fractions out of 100, always. Because I'm dividing, that's what allows me to move my decimal 2 places over. Okay, so it's 1 and 30/100. Or 1 and 3/10. 32%, again, I start with my percent. Percents are fractions out of 100 always. I divide, which makes my decimal go over 2 places. I have 3/10 and 2/100ths. Or I could write 32/100ths. As always, if you have a question, please come and talk to me.